In 1991, Russia lost the factory that built its most important military cargo aircraft. Not because it was destroyed, not because production stopped, but because overnight the country that factory belonged to no longer existed. When the Soviet Union collapsed, the production line for the Ilyushin IL-76, the backbone of Soviet military airlift, suddenly found itself outside Russia's borders, and with it disappeared something far more difficult to replace than buildings or machinery: the accumulated knowledge required to build one of the most complex transport aircraft in the world. To understand that, you have to understand what kind of machine the IL-76 actually is. Think of military airlift as a spectrum. At one end, you have tactical transports, aircraft like the Lockheed C-130 Hercules, tough, versatile, beloved by operators everywhere. They can land on dirt strips, reach remote mountain outposts, and get in and out of places no other aircraft will attempt. But there is a ceiling to what they can carry. A C-130 cannot move a tank. It cannot transport a mobile radar system or a field hospital. The loads that actually move armies are beyond it. At the other end of the spectrum sit the true heavyweights, the C-5 Galaxy, the Antonov An-124, aircraft that can swallow entire helicopters, that can carry payloads measured in hundreds of tons across continents. But that capability comes with costs that go far beyond fuel. They require long, well-maintained runways. They need enormous ground crews. They cannot operate from improvised airstrips cut into a Siberian forest or a Central Asian plateau with no infrastructure within 200 kilometers. The IL-76 sits between these two worlds, and that in-between space is where engineering gets brutal. The aircraft has to carry up to 60 tons across 5,000 kilometers. It also has to land on unpaved runways with a minimum landing run of 450 meters. It has to tolerate temperatures from -60 to +50. It has to keep working when the nearest qualified maintenance technician is a 6-hour drive away. You cannot optimize for any single one of those requirements without compromising the others. Every design decision is a fight between competing forces that do not want to coexist. And that complexity is precisely why heavy airlift aircraft are never produced in large numbers, why the manufacturing ecosystem behind them takes decades to build, and why losing that ecosystem quietly, overnight because of a political map change, is not an inconvenience, it is a strategic crisis. Russia understood this. The decision was made to transfer IL-76 production to the Aviastar-SP facility in Ulyanovsk, said to be one of the largest aviation production facilities in the world, a complex built in the 1970s with a runway originally constructed as a reserve landing strip for the Buran space shuttle program. The bones were there. What was not there was the knowledge. Aerospace production is not a set of blueprints. It is an ecosystem. It is the engineer who knows that this particular joint requires exactly this sequence of torque application, not because the manual says so, but because she has done it 700 times and she knows what failure looks like before it happens. It is the supply chain manager who knows which subcontractor delivers aluminum sheet stock 2 weeks late in February, every February, and has already accounted for it in the schedule. It is the production rhythm, the collective institutional understanding of how to build something this complex without it consuming itself in rework and delay. That knowledge was in Tashkent. Russia had to rebuild it in Ulyanovsk, from nothing, under economic collapse, under sanctions that tightened with every passing year, without access to Western tooling or components. The task was not to restart a production line, it was to reconstruct one from memory. What emerged, eventually, was not the same aircraft. The IL-76 MD-90A is a fundamentally redesigned machine. The wing structure was rebuilt, with a new center section achieving a 20% reduction in structural weight while increasing load capacity. The landing gear was reinforced. The cockpit went from analog instruments to 6 multifunctional digital screens, and the engines were replaced entirely. The old D-30 KP turbofans were out. replaced by the PS-90A-76 TAF, the same high-bypass turbofan family that powers the commercial IL-76 300. The new engines deliver greater range, lower fuel consumption, and significantly reduced maintenance burden in remote operating conditions. Inside the factory, something equally significant happened. The new Aviastar assembly line was built around precision automation rather than manual alignment. A laser positioning system now governs how fuselage sections, wings, and tail assemblies come together, guaranteeing accuracy that the older methods could not consistently achieve. According to UAC, the new process reduced labor requirements by roughly 40% compared with the previous assembly method. The workforce at Aviastar expanded to approximately 13,000 employees. The factory built a training center, a technical high school for line workers, and housing for 85% of its staff within the facility complex itself. Quietly, in a city 900 kilometers southeast of Moscow, an industrial capability was being reconstructed. Then came the hard years. The first IL-76 MD-90A rolled out of Ulyanovsk in June 2014. Serial production was supposed to follow. It did not quickly. In 2016 and 2017, no aircraft were delivered. Zero. The production chain was still finding itself. In 2019, 3 aircraft reached the Russian aerospace forces. That was the first real signal that the system was stabilizing. 3 more in 2020, 6 in 2023, 6 in 2024, 7 in 2025. 7. Say that number out loud, and in any other context, it sounds like failure. Boeing or Airbus produce more aircraft in a single day. But this is not that context. Across the entire global aerospace industry, heavy airlift programs typically operate between 5 and 15 aircraft per year, and anything within that band is considered stable production. The C-17 Globemaster III production line, one of the most capable strategic airlifters ever built, closed permanently in 2015. The United States still operates its existing fleet, but the tooling, the jigs, the supplier networks, gone. Restarting that line would take years and billions of dollars, and there is no guarantee the institutional knowledge still exists in the right combination of people to make it work. China is developing the Xeon Y-20, its own answer to the heavy airlift gap. Early production moved slowly, as it always does with aircraft in this category. The learning curve is not a metaphor, it is a real phenomenon. Each aircraft a factory builds makes the next one slightly faster, slightly cheaper, slightly more consistent, because the workers know a little more than they did before. That accumulation of knowledge is what analysts were watching in Ulyanovsk, not the number 7, the trajectory behind it. 6, 6, 7, with a stated target of 12 per year within 2 years. That is a production learning curve moving in the right direction. That is a system stabilizing. The engineers who rebuilt this did not do it from a blueprint. They did it from something older and harder to transfer. The understanding of how a complex machine fights back when you try to build it, and how you fight back in return. That knowledge lives in people, not documents. It took Russia 15 years of stops and failures and restarts to accumulate it in Ulyanovsk. The C-17 Boeing line closed in 2015, and that knowledge began dispersing the same day. The question the IL-76 production story leaves open is not whether Russia has rebuilt its airlift capability. It has, quietly, in a city most of the world cannot locate on a map. The question is what happens to the countries that chose not to, and whether the industrial capability to build these machines, once lost, can ever be truly recovered, or whether it simply passes to whoever refused to let it die. If you want more stories about the aircraft and industrial decisions that shape the world without anyone noticing, subscribe to Avia Tales. Hit the bell and join a community that follows aviation beyond the headlines. See you in the next one.